This is for the 6.10 lesson today. We start off with the warm-up, and then we'll move into the 6.10 notes on the next page. So starting off with, similar to what we have had for homework the last few days from 6.8 and 9, we're going to practice classifying whatever this polygon will be using the vertices given and explain why we did that. So let's walk through. I'm going to just do a little sketch over here, and then it's okay if it's not going to be exact. It's just to get an idea of what it might be, and then we'll show what work we need to show. So we have 3, 5, W, and 5, 0 would be X. Y is -3, -4. And Z is at -5, +1. Okay, so looking at that shape that now we've drawn, it looks like maybe it's a parallelogram, and by looking at just the slopes, we should hopefully be able to determine if it's a parallelogram versus like a rectangle, if there are right angles there. So let's go ahead and find the slopes. And again, you can either use the slope formula or rise or runs. This time I'll just go ahead and do slope formula since the last time we saw this was with rise or run. So ZW would be 5 minus 1 divided by 3 minus a -5, which is 4, and these would be plus signs, so 8 or 1/2. So that's my first slope. And then we find the next one. I'll just go in order. So WX. WX is 5 minus 0 and then divided by 3 minus 5. So 5 over -2 is the slope for this one. Then the next one should be the same as ZW because this is going to hopefully be parallel. XY. And these ones we do 0 minus a -4 and 5 minus a -3. Remember, the way I go through my numbers does not have to be the exact same way you do yours. They can be switched, but make sure the bottom is switched as well. But we should get the same answers because 2 negatives make a positive here and here. So we have 4 8s, which is, again, 1/2. And finally, the last one, the ZY is what we're looking for. And so this would be let's do 1 minus a -4 and then -5 minus a -3. So again, positives, 5 over -2 is what we get here. And again, that's the same thing as what I had there. So we do see that we have 2 pairs of opposite sides parallel. You can either write that down here or in your explanation. I'll just go ahead and write down here first, and then we'll write in the explanation. So segment ZW is parallel to segment XY, and segment WX is parallel to ZY. ZY. Okay, so those are the ones that we know are parallel, and we can clearly see we don't have any opposite reciprocal slopes, so we know that there's no right angles here. So this would mean that quadrilateral WXYZ is a parallelogram because it has 2 pairs of opposite sides parallel, since they have the same slope. And I'd still like to just kind of reiterate with this yellow sheet and kind of what it says here for the definition or what makes it a parallelogram. It's the second one there. If both pairs of opposite sides parallel, then parallelogram. Just as your if-then statement that says what it is. So if both pairs of opposite sides parallel, then parallelogram. Or you could say quadrilateral is a parallelogram. But that's good enough for your explanation. As long as you're mentioning that the slopes of the opposite sides were parallel, that's good enough. You don't have to mention anything about the slopes, the adjacent slopes not being opposite reciprocals, but you can include that note if you want to, because in case you were wondering, could it be a rectangle? It can't, because we can see what the slopes are. Now, we don't have to find the distances or the lengths here, because we already know it's a parallelogram and it can't be any other shape, because we've already kind of checked the slopes. It has to just be a parallelogram, so we don't need to bother with finding the lengths unless you were to find like the area or the perimeter if it asked to do that, which it did not. Okay, so let's go to the next page and we get to how do we find some missing coordinates now using the same ideas that we've been practicing. We're going to kind of be like working backwards a little bit. So it says, in the previous lesson, you were given the coordinates of 4 vertices of the quadrilateral, like we just did, and asked to classify what shape it was. Now you're going to be given the information about the quadrilateral and be told a few of the coordinates, maybe 3 of them, and be asked to find kind of the last one, and you have to use your like calculation, still the slope and the lengths and things like that to help you figure out what it could be. So we have a quadrilateral ABCD with the following points. We'll go ahead and plot the 3 that we do know. We don't know the last point. We don't know point D. That's what we're trying to find out, and we know it's a rhombus. You definitely need to know what it is in order to find that last point, because you could have lots of different answers if it was a different shape. But let's start with what we do know, which is 4, 7 is the first point. So this would be letter A. B is at 9 and 7. So there's B. And then 6, 3. And this would be C. Now we just don't know where D is. Now there can be sometimes more than one correct answer, but let's at least connect A, B, and C so far. So you can kind of see what it's looking like. Depending on the shape that you're working with, you may have potentially more than one right answer. On this one, though, since it's a rhombus, we don't have very many options here. But you can kind of get an idea of like what general area this is going to be in, and you have to spell out the letters A, B, C, D. So you can't like put it off in the corner over here because it wouldn't spell that letter out. If it says the actual name of the quadrilateral, you have to make sure it spells it out. So if we know it's in the general area of this, how do we know exactly where it is? Well, this is where we use slope. You find the slope of what we do know for like AB, for example, or BC. The slope of AB is a horizontal line. So that means this is also going to be a horizontal line. We know so far that the coordinates of D, when I write the coordinate down, like x comma y, the y value has to be the same as what C has, which is 3. It has to be in the same line as this. We just have to figure out how far to go across. And that's where slope comes in. So I'm going to find the slope of B to C. And so that's 1, 2, 3, 4, negative 4, and 1, 2, 3. So if I'm going to use the slope of 4 and 3, and I know then that this means that the length here is 5, I can use that same slope of going down 4 and instead of going, or down 4 and left 3, just like I did here. The problem is I'm not going, actually this is left, sorry, negative 3. So I can do the same thing, down 1, 2, 3, 4, and left 1, 2, 3. And once I have that point there, I'm going to call it point D, and I can even connect it to double check that this looks right. Right, so this is definitely, and it looks like a rhombus, and I could double check with making sure the opposite side is definitely the same. So this is up 4 and right 3, which means also that if I did find the hypotenuse, I could use Pythagorean theorem to find it, or the distance formula. It's going to come out to 5. You might not realize that, but it is going to be 5s, which are also the same as the other 2 sides. All of the sides are definitely 5s. So the coordinate would be, looking at where D is, 1, 3. And that's how we found what the coordinate is. How do you know, it says, so we can write down how we found that out. It's something about knowing that a rhombus has the same length of their sides. So side lengths of a rhombus are congruent, as well as both pairs of opposite sides of a rhombus are parallel. Both pairs, opposite sides, parallel in a rhombus. Okay, so that's how we mentioned both those things. We used slope and kind of knowing the idea that 5 had to be the length of all the sides, and it would do that. If the slopes are the same, then you would use Pythagorean theorem to see that, yep, the side lengths would all be 2. But you can use your calculator, of course, to help you to see that. Let's try a couple more. So it says this time we have a square. The square's name is QRST, and so far we only know two of the coordinates, Q and S. It kind of skips over R, and we have to find T as well. But let's start by writing out Q and S, or graphing Q and S. So -2 and up 5 would be Q, and 4 and up 5 is S. So it's good that they're on the same line together, but this, if I connected this, this is not one of the side lengths of the square. This is actually a diagonal because it goes QRST. So maybe R is somewhere up at the top and S or T is somewhere at the bottom, and it could go QRST like this. So let's think through what this would be, but it does help to draw this in just so that we can work with the diagonals to help us here. Because the diagonals in a square, I'm going to write this part here now before we write down what our answers are for R and for T. I want to write down that the diagonals of a square are perpendicular and congruent. They also bisect each other. So actually another and. Bisect each other. So we're kind of using all three of those things to help us figure out the new placement for R and T. This, if you didn't remember some of this stuff about a square, this is where this yellow sheet would come in handy again, that you would want to look up and say, okay, what do I know about a square? And so we know, of course, the 4 congruent sides and the 4 right angles, but specifically mentioning diagonals, that's going to be further down. There's not anything specifically with square because remember, rectangles and, or a square is a rectangle and a rhombus. So everything that it says for rectangles, like diagonals are congruent, everything it says for rhombus, diagonals are perpendicular, and everything it says for parallelogram, where it would say the diagonals of a parallelogram bisect one another. So all three of those things kind of put together here. Well, let's try to see by using all of that if we can figure it out. If this is a horizontal line, then the diagonal for the, or the other diagonal of the square should be perpendicular, which means it's going to be vertical. Okay, so we do know that it's going to go up and down like this, but we want it to do it at the midpoint. So here's where you're going to look at your full segment here. This is 1, 2, 3, 4, 5, 6. You want to go exactly to the middle there so that it's bisected. Because remember, diagonals are bisected in a square. And if I know that it's got to be at this point as the midpoint, I know it has to go up and down like this. I just have to figure out how far up and down to go to get to my other 2 points. And so this is where, again, the diagonals are bisected. If this is 3 units to get to the midpoint, this needs to be 3 units up and 3 units down. And so that would be R, and this would be T. And you could just draw it out first to see once you draw all of those sides together, and then we can write down what the coordinates are. Okay, and double check that it all works, that it's definitely bisected, perpendicular, and congruent. Of course, they're all 3s or 6 for each of those diagonals, 3, 3, 3, and 3. So that's how we know it's right. And so R is sitting at 1, 4, 5, 6, 7, 8. 1, 8. Right? And T is sitting at 1, 2. All right, and we just found our 2 points. Okay, so that's the idea kind of for homework as well. There's a bunch of these that you can try out. You don't have to explain every single one or anything like that, but hopefully by seeing that this is how you kind of approach each one, thinking about what the characteristics you have. All right, and so then the last one deals with rectangle. Now this one gets a little bit more abstract because now there's not numbers anymore, we're using letters. And some of the homework is going to do this too, and I know it can be kind of tricky, so I'll see if I can go over one of them on the practice. If there's one that has just letters to it, we'll go ahead and try that one out as well. Actually, I'll do all of the practice ones, but you can see how long they take. All right, so a rectangle is in quadrant 1. Let's go ahead and draw quadrant 1. This is quadrant 1 where it's just the positive x-axis. And I have a rectangle that's in this quadrant, but before I draw it, let me read through it. It says it has one vertex at 0, 0. All right, great. That's an easy one. That's one vertex. It has a height of h and a length that is twice its height. Okay, so if the height is h, that means the length would be 2h. And then we want to figure out the coordinates of the vertices of the rectangle. So let's try to draw this now. If I know that there's some kind of a rectangle, I want to use like the x and the y axis to help me draw this. And it doesn't matter how big your rectangle, you know, how wide or high you want to make it, because we're going to label it with letters, not numbers. But you have 4 points here. It's saying here that this one is 0, 0, of course. That's the vertex we started with. You can extend this a little bit if it helps to see that this is the first quadrant. And then the height, remember, they said it has to be a height of h. That's what this said here. So from here to here, this is h units. Okay, so h units for that height. That means I need to eventually figure out that coordinate, but let's come back to do that. This is also going to be h units. Do it like this, actually. Okay, so we have h, and then it says 2h for the length. That means like from here all the way to this point, it's 2h, and then same thing for this bottom part. It would be 2h all the way across. Okay, so we got all of our sides kind of labeled. Now we just have to work with the vertices. And what we know about vertices is if you see the origin, we know it's 0, 0. If something is on the x-axis, that means that its y value is 0. Because it's like saying move some distance to the right, a certain amount, and then don't go anywhere up or down. Stay where you're at. This one, though, the y-axis, or the y-intercept, is always 0 first because you don't go anywhere left or right, and then you're going up a certain height. Well, here's where you're going to use these letters, the h's that we kind of are working with. This one here goes up h units, so this will just be h. Whereas this one here goes right 2h units because it's like double that, and so this would be 2h. And that's what these look like so far. Finally, we just need to get the last coordinate here in this corner, which goes right 2h. Remember, when you write a coordinate, you always do the x direction first, and then up h, because you're kind of taking the coordinates from each of these and putting them in the right spots. Like the x value is 2h, the y value is h. And we just figured out all of those coordinates of a rectangle. That would be it. All right, so that's kind of it for like the new part of the notes. The rest is all practice here, which you could pause at this time and kind of try out, and then we can always watch the rest at a later time, or if there's time in class to even go through it. All right, so to go through the rest of this practice, 6.10 practice is finding missing coordinates, and it gives us 3 of them. We need to find the last one. Kind of similar to the first question we tried. Let's go ahead and label these. 1, 1 is P. 2, 4, oops, 1, 2, 3, sorry, this is 4, this is Q, and P, Q, and R is at 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so we have P, Q, and you don't have to connect them just yet, because you could kind of see what the possibilities are. When it says what are the possible coordinates of S, specifically for a parallelogram, you actually have a lot of choices here. And so let me actually take that part out because I don't want you to get confused with thinking that is a coordinate. So now that we have these 3 points, you can kind of visualize like different ways that you could put S in a spot and maybe it would form a parallelogram. So if I put like S right here across from like where Q is, that could be one way to form a parallelogram. Because remember, parallelograms can be rhombuses and rectangles and squares as well, so it could kind of meet all of those different criteria. But here's where you can use slope to help you figure this out too, because you're finding like how far away things are. So if this is like up 3 and right 1, and then to get to the next one, you could also go up 3. Oh wait, sorry, you would kind of go the other direction. So you could go right 3. And also come here, this would be one possibility, right 3 and up 2 to get to this point S, because this would be like a rhombus with the same slope for R to S as it is for Q to P, because it's up 3, right 1, this is up 3, right 1 as well. Okay, that's one possibility. For S, let me write down that one. It's 1, 2, 3, 4, and 3. Okay, then we could have one, maybe, there could be one in the negative direction kind of here, which is harder to do because it kind of falls off the graph. Same thing up here, it kind of falls a little bit off the graph because you could have something like P, Q, and then S, and then R. So it kind of forms like a parallelogram from these two connected, and then it would be up high like this, and then you would connect the rest of those. So if you were to use the slope, the same up 3, right 1, 1, 2, 3, right one would go like here for S. That's one way to kind of think through where S could be, and it would be, let's see the coordinate here, 1, 2, 3, 4, 5, 6, and then this goes off, so it's at 9. S is at 6, 9. That's another possibility. And then finally, the other option would be if it goes out this way. I'm just going to write down what the coordinate is in case you want to try that one, but it could be down here at -2 and -1, which again doesn't quite fit on here, but that's another option. You don't always have to find all of the options, but they are there in case you want to. All right, then it says an obtuse triangle with a base of 2 units and a corresponding height of 3 units has the following coordinates. Let's go ahead and plot them. A is 0, 0, B is 2, 0, and C, we need to find what that is. Again, there's a lot of answers that are possible for this obtuse triangle. We just have to think through how you're going to show which angle is obtuse to help you figure that out, because we need to find where C is going to be. Like you could, for example, let's say I want to make angle A the obtuse angle. Then I would think, how am I going to draw this so that angle A is a bigger than 90-degree angle? Well, I could make it go like something like this, right, where A and B are connected, and I could have C somewhere down here, and I could connect it like this. That's one possibility. Or if I want to make angle B the obtuse angle, then I could connect a line like this and create a line going like this. But the idea is you have to make sure the height is 3, right? So we have to go up 3, and then you could figure out how far out to go to create that obtuse angle. So maybe like this. Sorry, not that one. Where it goes height of 3, but it also goes right 3. That could be one possible answer for C, 3, 3, because it meets the criteria of the base of 2, height of 3, but still has this obtuse angle right here for angle B. Angle B is obtuse on this one, versus this one down here could have been an obtuse angle this way, and same thing. You could have multiple answers there. And you could have others too. If you decide you want angle C to be your obtuse angle, then you could even do others. Right? So I'm putting some examples here. The other one, you can try these out later on, and if you have questions, just bring them with you. All right, so a square has vertices 0, 0, M0, and 0M. I know this gets a little bit harder because the letters generally do make it a little bit confusing. So this right here would be 0, 0 at your origin. If it's a square, try to make just all the sides the same. And then we have M0 that would be on the x-axis. 0M would have to be on the y-axis. That means this point right here, the fourth vertex, has to be MM, because you're going right M and up M to get to that point. So the fourth vertex is M, M. All right, and then we're down to the last few here. We have coordinates, find the coordinates of any unlabeled vertices, and then find the indicated lengths of each one. Now this is going to take a little bit more time because of you have to use the distance formula with these different letters, which makes it a little bit harder to do. I'm going to actually just write down what the answers are for these. They are posted on Canvas with the worked out solutions, but just for the sake of time, if you have questions on these, then of course we can go through them. GH is 2K root 2. FH is K root 5 for the ones that we had to find. And for these coordinates, since we had a label, let's do that part at least. So, so since it's K units, G would be 0K, F would be 0, 0 because it's a vertex. And since these are congruent, J is also going to be K0. But then to get to this point down here, which is at H, the problem is we have to see what like this distance would be, and that's why we had to kind of use these measurements a little bit to help you find what K would be, or what H would be. And so it's going to go down, so if you're kind of writing down how we get to this point, you can see how far down we're going and how far right we're going. And so it ends up being negative K for the distance that we're going down, and 2K for the distance that we go to the right, because it's another one of these, exactly the same amount. All right, and then again, we'll go over some of these later on. The coordinates are definitely much more complicated on these, and so there's none of those on the quiz, or the, I'm sorry, the test or the quiz. But these, if you wanted to at least just write them down, here's what you would get. It does come out to a fraction, which makes it a lot harder. The coordinates I'm going to go ahead and just let you use from what's posted on Canvas finally, there is one last problem on the next page that deals with midpoint a little bit. It says find the coordinates of n using the midpoint formula essentially here for p and m. So you can either write out the midpoint formula or just use, calculate what it is without writing it all out. But it's 0 plus 2h divided by 2 and 0 plus 2h divided by 2 again because they have the same x or y. And so this comes out to h and then h again. So h comma h for n. All right, we found that. Now it wants us to classify this triangle as like what type of triangle it could be, isosceles or and so on. So we would check the side lengths. Since this is 2h units and this is 2h units, they are congruent to each other. And so you would double check if what this third side is using the distance formula with PM. Using the distance formula, you end up getting to, I'm just going to write what it came out to again, 2h root 2, which is definitely not 2h. So this is then an isosceles triangle. And finally, the last one here, triangle DEC is congruent to BOC, so we know all the corresponding sides that match up, like for example, these two are congruent, but we are asked to find these coordinates, so it's based on like exactly the same distance that they go. So if this is right h, and this is h again, k is halfway, but we want to go all the way to up to 2k, the y value here would be 2k because it's in the same line as point D here. And for the x value, you're seeing how far away you're going. So if this is h units, and this is h units across, that would be 2h units. So E would be 2h comma 2k. All right, and that's it for this practice. And again, if you have more questions on these, you can bring them over the next few days. I'll go over what I meant.